everyone, have a nice and a good day. So today I'm going to present to you about my bachelor degree project to Bmmu4774. My project title is Development of Packaging Tray from Sugar Plant Fiber Mechanical Properties. So my name is Abigail Livanusi and my ID is B09-10160. So my course is Bachelor of Manufacturing Engineering Technology and Process Technology with Honors. So my project is under supervisor T.S. Kamal bin Musa and my co-supervisor is Dr. Ridwan bin Jumaidi. Next is the contents of my presentations today. So today I'm gonna present to you all about the problem statement, objective, scope of study, literature review, methodology, result, discussions, conclusion, and lastly the commercialization potential. So let's move on to the problem statement. As we can see here, there are three problem statements in my project, which is first one is the plastic pollutions. Which in these plastic pollutions, about 5 trillion pieces of plastic trash are disposed and found in the all water reservoir in whole New World. This is from God's Wills and Gospel 2019 research. These commonly plastics are non-biodegradable plastic. Secondly, for the problem statements is agro waste, which can find out that sugar plant fiber that is a byproduct from the agriculture sectors are commonly being thrown and it will become an agro waste. This is from Nick Bahaki 2021. These waste are smelly and can bring disease from fly. Thirdly is the limitations of the thermoplastic starch. As we all know, starch are natural occurring element with easy biodegradable properties, but it is low in terms of mechanicals and thermal performance. This is from Zoo 2015. So the objective of my study are, as we can see here, is first to determine the thermal properties of biodegradable thermoplastic cassava starch TVCS reinforced with sugar plant fiber SPF. Secondly, to investigate the mechanical properties of biodegradable TPCS reinforced with SPF. And lastly is to produce the biodegradable tray from TPCS reinforced with SPF. So these are the scope of my study. As we can see here is the primary organic materials. Secondly, to produce the TPCS reinforced with SPF with a different ratio. Next is the testing of this sample with a different testing method. Then lastly is to produce the biodegradable tray from TPCS reinforced with SPF. So the literature review. For the first literature review is the cassava starch. Cassava starch is known as the fifth most largely produced starch crop and the third most extensively eaten food source in a tropical region. As you can see here is the properties of the cassava starch that contained in the cassava root. So next is the glycerol. As we can see here, glycerol is the plasticizer in productions of thermoplastic starch-based composite. Glycerol enhance and improving the thermoplastic polymer flexibility and workable. This is from Katrai Nyok at 2010. So next is a TPS. It is a thermoplastic starch. It is usually made from a number of natural sources, including red rice, maize, potato, pea, and other molds. This is from Frost 2010, which this content are biodegradable and compostable. But in terms of deformations, it has low tensiles and as well as water resistant, which it has a limited potentials as a packaging material. This is from Altaya and Plum 2020. So next is a beeswax. As we can see here, beeswax is a formation naturally occurring from honeybees. It can help to decrease the absorption of water as it acts as a wax. This table shows the properties of beeswax. It is from Points and Terms 2021. So moving to the next part is the sugar plant fiber. As we can see here, sugar plant fiber contains of 66.5 cellulose, which it is in terms of mechanical quality is excellent. So as we can see here, this is the table mechanical properties, which it has a high tensile strength, which W is 15.5 MPa. So the next table is the part of a sugar plant fiber with the diameter and its water absorption percentage. So let's move to the methodology of my project. So these are the flowchart of my project. As we can see here, the first step is the raw material selections. Then after that, to create the TPCS, which is thermoplastic cassava starch, and next is TPCS reinforced with SPF with a different ratio, and we analyze this different ratio samples with a different testing. After that, we collect the data, and then we processing the tray, and finally making conclusions and end of the project. The raw material is a sugar plant fiber. So the sugar plant fiber was supplied by Adha Enterprise, which is located at the Jempol, Negeri Sembilan. So after we get this sugar plant fiber, I clean it up from other contaminants And after that, after it be cleaned, it will be cut off into a short fiber around 0.1 to 0.3 cm. Then it will be grind, and after grind, we will filter it to remove some dust. And after that, the SPF that produced are been stored in a clean container. So next is the cassava starch. This is the cassava starch that I've been used, and this is the general properties of the cassava starch. This is the glycerol. This is the glycerol that I have been used in this project, which is the specifications are as we can see in this slide. So next is the beeswax. So this beeswax that I have been used. So here's are the specifications of this beeswax. Next is the preparations of TPCS. So this is the preparations of TPCS, as a mixture of TPCS is 30%, which is 70 is content of cassava starch and 30% is the glycerols. As we can see here, these are the process making of the TPCS. I wet the cassava starch, then the glycerol, then it will be mixed up, and after that it will be stored in a clean container. Preparations of TPCS reinforced with SPF. As we can see in the tables, there are sample which is with a different ratio. In this ratio, we will wet it according to the ratio given. Then we'll be mixing it. Then after that, mold will be prepared, and we will put the Malima film, and we will compress the mixture that been mixed and put it in a hot press for 1 hour around 155 degrees Celsius, and the samples will be produced. So next is the development of packaging tray reinforced with a sugar plum fiber. So the development of these thermal composites fibers that I have created are using a 20% which apply in the fabrications of this tray. So first, it is same as a previous step, but in this step, it is different in terms of the mold. The testing method, I'm using 5 type of testing, which is first is TGA, which is thermal gravimetric analysis. It is to classify the material thermal degradable activity in relations of weight loss due to the increasement of temperature. Next, tensile and fracture testing, which I'm using Shimizu machines, which with a different type of American standard. For the next is the Fourier transform infrared spectroscopy (FTIR). This is to detect and to see the bonding of the crystallizations in each sample. Here is the SEM method. It is a scanning electron microscope. This machine is to see the morphologicals of the structure of each sample after time. So let's move on to the result of my project. For the thermal analysis, we can see there are 2 graphs, which is TGA and DTG, which is TGA stands for thermal gravimetrical analysis, which in this graph you can see the weight loss of the composite at the maximum decomposition pace decrease following to the increasement of the fiber content. So it shows that additionals of the fiber has reduced the weight loss of the composite, indicating the improvement of thermal stability. Balachandran 2019 said that the weight loss will increase in terms of the increasement of temperature, and it will reduce 2 to 3 levels of stage of characteristics depending on the natural fiber, the initial time, and the chemical treatment. So as we can see in the graph, there are 2 level of the decreasement of weight. It is from the slower, which is 30 to 300, and extremely at 300 to 390. So for the DTG, as we can see here, it is like a V shapes, which the first weight loss, as we can see, is around 30 to 330 degree, which this is attributed to the evaporations of moisture from water. The sample with the high fiber has lower decomposition peak, inducting lower amounts of starch in this sample since it was replaced by the fiber. So Mascot and Ramisukas 2020 stated that fiber enhanced to the starch metric increase the heat stability because fiber and metric adhered effectively, leading to the minimal loss in this study. So as we can see here, the lower peak is at 40% of the SPF. So next is the mechanical testing result. As we can see, the mechanical testing result for the first one is the flexural testing. In this flexural testing, we can see there are 2 graphs, which is the flexural maximum stress and flexural strength. So the trend graph of flexural strength, as we can see, the graph are slowly rise up until 30%. jump up 40% and decrease on a 50%. According to Konyuzekoka Kamizer 2009, this is because of the few factors influencing the composite performance, including the fiber and the metric power as well as fiber to metric interactions. This proves that the fracture strength rose as the amounts of the sugar plum also increased but decreased when the quality of fiber was exceeded. For the fracture maximum stress, the trend of the graph, as we can see here, are slightly increased until it reached a 40% and drop a bit at a 50%. The unforced matrix in a metal or polymetric composite is usually capable in irreversible plastic deformations, and the metric fail strength is usually much greater than that of the fiber. This is from Huckles 2018. Tensile testing, which is, we can see here there are two graphs. There is tensile strength and tensile modulus elasticity. For the tensile strength, the trends of the graph, as we can see, are slightly increased until it reached a 30% and drop a bit at the 40%. According to Jumaidin 2017, the increasement of SPF reinforced with TPCS will ensure the tensile strengths are more greater and improve in terms of the tensile strengths. For the tensile modulus elasticity curve, as we can see here, the trends are slightly increased until it reach 40% but decrease at 50%. According to Ishaq 2013, the failure may be attributed to poor strength of fiber, where the fiber is pulled under the actions of applied force. So next is the chemical interactions and metallurgical characteristic. So let's move on to the result of the FTIR. So as we can see here in this graph, we can see that the existence of OH group in the starch and the fiber was suggested by strong peak at 3200 to 3500. Starch are particularly sensitive to the water molecule due to the presence of the hydroxy groups. This is from at Hatch 2017. Humaidin 2017 found that cellulose and hemicellulose in a natural fiber contribute to the presence of the OH bond. The existence of the OH groups in the fiber was revived by the strong peaks at 3200 to 3500. So next is a SEM result, which is scanning electron microscope. So for the figure A, this is a 0% fiber. The structure are like glossary shapes, which support by Putra 2019, where the structure are familiar to the beeswax and carbon nanotubes structure. For the A part, the structure are like a homogeneous structure. So for the 10% SPF, for the B, we can see there are void happens in this. It shows a good adhesive structure, but the fiber and the matrix are separately because they occur a void. So there are weak interactions bonding between the SPF and the mixture. 20% to 40% compositions SPF shows that the evidence of a good adhesive structure where the fiber and the matrix are bind, indicating a good interferential bonding between SPF and the matrix. Due to the low reinforcing agent, the specimen with 50% of SPF relieved structures of void and defective interactions between matrix and fiber when it reached to the limit of adhesions. TPCS can longer bind the SPF. This SEM support the result of tensile strength result. As a conclusion, the objectives are achieved. As for the first objective, it is achieved through the additions of SPF sustainably increase the tensile strengths, tensile modulus, flexurals, and also the flexurals modulus. Therefore, the good uneven distribute on the SPF in the metric contribute to improve the composite strengths. So secondly, the objective is achieved through the TGS test that relevant the additions of SPF has greatly increased the composite thermal stability. And lastly, for the third objective, it is achieved by introducing a new biopolymer through this analysis by preparing the material specimen using the cassava starch glycerols as a pasteurizations, modifications of beeswax, and also some SPF as a reinforced agent. I have created and successfully developed this TPCS reinforced with SPF strength. So finally, this is the commercialization potentials. As we can see here, this is the cost of the product. The cost analysis of each product as seen here is for the cassava starch, it only costs 0.031 cent. For the glycerol, 0.0035 cent. For the beeswax, 0.11 cent. For the sugar plum fiber, 0.032 cent. So the total cost for producing a single unit of biodegradable tray from SPF is only 0.18 cent in total. I have made a survey for these potentials of the biodegradable tray. There are positive feedback given by consumer during this survey. This is the customer feedback. So the acceptable price range for the customer to purchase this product are around 1 ringgit to 3 ringgit for a single purchase unit. That's all from me. Thank you very much. Bye.